Hello everyone, in this video we're going to explore topic 8.11. What's the method revolving around the x or y axis? Alright, to find the volume of a solid of revolution with the what's the method, use one of the following. The first one, horizontal axis of revolution. So suppose you have two functions f of s, it could be something like this. And the function g of s is could be something like this. Now two functions intersect at the points right here. Alright, so let's create a regions. Now we need to revolve these regions about the x-axis, right? So we get the solid something like this. When you see a hole in the middle right here, then you're gonna use the washer method. Alright, so basically the volume is going to be pi linear from A to B of the bigger radius, which means the outer radius, right? The distance from the outer function right here to the center. The center is the axis of revolution, right? So the center is right here. So the distance from here to here is the outer radius. Subtract the inner radius, which means the lower function right here, to the center of rotation, right? So it could be from here to here is the inner radius. So that's why you have the formula right here. Now look at the right hand side. Suppose I have the function f of s is right here, and the function g of s is right here. Alright, now the shaded region should be this one. If I want to revolve this one about the y-axis, right? So I will get this solid something like this. The center of rotation is the y-axis right here, right? So the distance from the right function to the y-axis is the bigger radius, right? The difference from the left function to the y-axis is the inner radius, right? So it could be capital R in terms of y square minus little r in terms of y square dy, right? So you have the formula right here. Now let's move on to example number 1. Using the question method, find the volume of the solid formed by revolving the region bounded by the graphs f of s equals square root of s and y equals s squared about the x-axis. Sketch the graph and draw a representative rectangle. Now to sketch this one, we're gonna let x equals 0, y equals 0, right? X equals 1, y equals 1, right? So if you graph it, it's gonna be something like this. Now to graph this one, we're gonna let x equals 0, y equals 0, right? X equals 1, y equals 1, right? X equals 2, y equals 4, right? So if you graph it, it could be something like this. And the shaded region should be this guy. Now we need to find the intersection between these two graphs manually, right? So we're gonna let s squared equals square root of s, right? Then we're gonna square both sides, so we have s power 4 equals s, right? Then I'm gonna subtract s both sides, so I have s power 4 subtract s equals 0, right? Factor s out, so it's gonna be s cubed minus 1 equals 0, right? So then s equals 0 and s power 3 minus 1 equals 0, right? Then you have s equals 0 and s equals 1, right? That's why you have this guy right here, 1 and 0 right here, right? Now we need to revolve this one about the x-axis, so you're gonna get the solid something like this. The outer radius is the distance from the top function to the center of rotation, so it could be right here. This one is rs, right? The inner radius is the distance from the inner function to the center of rotation, right? So this one is little r of s, right? Now the inner function is y equals s squared, right? The outer function is y equals square root of s, right? So the volume is pi times the integral from 0 to 1. The bigger radius, which is the outer function right here, right? Square root of s altogether square minus the smaller radius, which is this guy right here, s square altogether square ds, right? Now, if you simplify, it's going to be pi the integral from 0 to 1 s minus s power 4 ds, right? Take antiderivative of this one is going to be pi times 1/2 s squared minus 1/5 s power 5, right? Evaluated from 0 to 1. Now substitute 1 for s is going to be pi times 1/2 minus 1/5, right? Substitute 0 for s is going to be 0, right? So the answer is 3 pi over 10. Now let's move on to question B. We're going to revolve these regions about the y-axis. Alright, so if you sketch a graph, it's going to be something like this. Let's get the representative rectangle. You know that the center of rotation is the y-axis, right? So the outer one is right here. This one is ry. And the inner one is right here. This one is little r y, right? Now, you know that the lower bound is 0 and the upper bound still 1, right? Now the outer function is y equals s squared. The inner function is y equals square root of s, right? You need to rewrite this one in terms of y, right? So I have y equals s squared. It's the same thing as s squared equals y, right? Take square root both sides, so it could be s equals plus and minus square root of y, right? Because this one is above the axis, so we're gonna take s equals square root of y, right? Now y equals square root of s, then square root of s equals y, right? Now you're gonna square both sides, so s equals y squared, right? So the volume is pi times the integral from 0 to 1, right? This one to this one right here, right? The bigger radius is the one right here, right? Which means square root of y, right? The smaller radius is this guy. It's going to be y squared, right? So we have square root of y altogether square minus y squared altogether square dy, right? Now I'm going to simplify this one. It's going to be pi times the integral from 0 to 1 y minus y power 4 dy, right? So take antiderivative of this one is going to be pi times 1/2 y squared minus 1/5 y power 5 evaluated from 0 to 1, right? So it's going to be pi times 1/2 minus 1/5, and it's going to be 3 pi over 10, right? Which is the same thing as the first one right here, right? Now let's move on to example number 2. Integrating with respect to y, two integral case, disk and quotient methods combined. Alright, find the volume of the solid formed by revolving the regions bounded by the graphs y equals s squared plus 1, y equals 0, s equals 0, and s equals 1 about the y-axis. Alright, now we're gonna sketch this one first, right? S equals 0, y equals 1. S equals 1, y equals 2. S equals negative 1, y equals 2. Right? So it could be something like this. Now y equals 0, which is the x-axis, right? Now s equals 0, which is the y-axis, right? so it could be this guy. X equals 1, which is this guy. Now the shaded region is this guy. Now if you revolve this one about the y-axis, it could be something like this. Now we're gonna split this solid into two shapes, right? The first one is from here to here, right? So this one right here, we're gonna use this method because we don't see the hole, right? This one right here, we're gonna use the washer method. Now I call these regions A, I call these regions B, right? So from 0 to 1, I have the radius right here. The radius in terms of y actually 1, right? Because the right one right here subtract the left one, which is 0 right here. 1 subtract 0 equals 1, right? So the volume of the solid A is pi, then 0 from 0 to 1, right? 0 right here and 1 right here. 1 square dy, right? So it's going to be pi y evaluated from 0 to 1, so it could be pi, right? Now, the volume of the solid B right here, we're going to use washer method, right? Because we have the hole in the middle right here, right? So, the bigger circle is right here, right? And the smaller circle is right here, right? So, we need to draw two representative rectangles, right? The first one is right here. This one is the bigger radius, so this one is called capital R Y, right? Capital R Y equals 1, right? Because it's going to be S right subtract S left, right? S right is 1, S left is 0 right here. That's why you get 1. Now, the smaller radius is right here, right? This one is little r y equals S right subtract S left, right? It's going to be S right is the quadratic right here. So we have the quadratic, it's going to be y equals S squared plus 1. We need to rewrite this one in terms of y, right? So I have S squared plus 1 equals y. It's the same thing as S squared equals y minus 1. Take square root both sides, so have S equals plus and minus square root of y minus 1, right? But we only take the positive one, right? So we have S equals square root of y minus 1, right? So this one is square root of y minus 1. Subtract S left, which is 0 right here, right? Because the center of rotation, right? So it's going to be square root of y minus 1. That's it, right? So volume of the solid B is pi times the interval from 1 to 2 right here, right? Of the bigger radius, which is 1 right here, square. Subtract the smaller radius, which is square root of y minus 1 right here. All together square dy, right? Now I'm going to simplify this one. It's going to be pi times the interval from 1 to 2 of 1 minus y. When you square this one, it's going to be y minus 1, and you distribute negative 1 right here. It's going to be negative y plus 1, right? dy. Now 1 plus 1 is going to be 2, so I just write 2 over here. Alright, so this guy turns out to be pi times 2y minus 1 half y squared evaluated from 1 to 2, right? So I substitute 2 for y is going to be pi times 4 minus 2, right? Minus substitute 1 for y is going to be 2 minus 1 half, right? Now I'm going to simplify. It's going to be pi times 4 minus 2 is going to be 2. 2 minus 1 half is going to be 1.5, right? And it's going to be 0.5 pi or pi over 2, right? Now you need to add this guy right here and this guy right here. So the final volume should be pi plus pi over 2 equals 3 pi over 2. This one is the final answer. And it's your time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand